Hello. This is, as you can tell by the screen, I'm looking again at 2024. And you may wonder, why am I looking again at the challenge from 2024? I thought I'd closed that all out with my videos on optimizing 2024. And the answer is, I got some comments on those videos. Or I got a comment. Which for my videos is a rare event. But I got on both of my optimized videos, part 1 and part 2. I got comments here. I'll put up the screenshots here. This was on part 1, telling me about a better way to do question 12, part 3, and then this was on part 2, asking about what I did for question 19, part 3. And I don't know about this first one. I don't know if question 12 is really, question 12 is really in need of optimization. I don't know if my answer to question 12 of 2024 is really in need of optimization. It's pretty fast already, as shown in my video, the optimized part 2 video at the end, where I give the timings of everything. However, this question here, this comment here about question 19 is completely fair. I do some very weird stuff working around the fact that my rotate function can only take bytes. And there's really no reason for that. There's no reason at all. I could just go ahead and change the function and make it generic. So I'm going to pull that up and see where we are. But first, I have some work to do to get to where I can even go ahead and do that. In between when I made that video and now, I got a new laptop. I switched laptops because something happened to the old one. And when I did that, I also switched laptop platforms. The old laptop was an Intel Windows laptop. This is an ARM Windows laptop. That part shouldn't make much difference, but it might change the timings radically. So really what I want to do is I want to rerun all of the timings. So first I'm going to have to go here into my list of 24 and say, okay, first I want to build all of these. So yes, you can see I already have the command. I've tried it. Let's go and let's build all these files. And you can see here it's going and it's building each of the executables, and it's working pretty fast. Now though, I have a bigger problem in that I don't have on this computer all of the input downloaded. I've downloaded it for 2 of the quests, but downloading it for more of the quests, but I need to download it for all of the quests, because of course if I try here, say quest 9, yeah, I guarantee you the answer was not 0 all the time. But that's just because it couldn't find the thing. And quest 10, yeah, just panics and panics and exits. So I need to get all of the input. Now, getting all of the input for Everybody Codes is a little bit tricky. If you want to look at how to get it, there is something on the Everybody Codes wiki that talks you through it, and it's It's quite elaborate. You need to use your session key, which, okay, I can store my session key in a file and pull stuff down. That's no different than what you have to do with Advent of Code. But the thing is once you get your session key, then you get the response. The response is inside a JSON file, which, okay, we can decode JSON, that you then need to decrypt using AES. I mean, there are crypto libraries in Go. I could write a Golang program to do this, or a Python program to do this. There are crypto libraries in Python. Or I could use a Python library that somebody else already has made up. So that's what I'm going to do. Okay, and auth token should be placed in that or defined in the ECD token variable. Inputs are unlocked as you complete. Okay, so I'm going to have to get all of the files, and okay, so first I'm going to have to get this token. I'm going to check where it reads the token from. Okay, it reads it from that and it calls expand user. So I can use it no problem on Windows. I will just use my user profile config ECD token. Okay, so $env $env user profile dot config. What is it? Config ECD config ECD, and then I need to make a file called token. So that I'm going to do off screen, so, because obviously I'm not going to reveal my token here. Copy. Okay, now I'm going to create a virtual env. So what do we have? Pi dash okay. Oh, do I not have the Pi launcher? Okay, Python. What version do I have? Okay, 13.3, that's fine. -m venv. Okay, make myself a virtual env for EC data. decent amount of time there. ECData, include ECData scripts, activate.ps1. Okay, and now I'm going to do pip install-u pip, because that's just what you do when you have a new virtual env, just as like a habit. Oh, right. Yes, as you can tell, I am most used to using Python not on Windows. So, fine. So now I'm going to do python-m pip install everybody codes data. Okay. Now input. Okay. Python import, or here, from ECD import get inputs. Data. Now I want to get the inputs for all 20 quizzes, so for all 20 quests, so for quest in range 1, 21, data equals get inputs, quest equals quest, event equals 2024. Fname equals input slash everybody underscore codes underscore E2024 underscore Q. Now I need a quest, but I need it as 2. Okay, I am blanking on the F syntax, so I won't use that. I will use the old printf syntax. Okay, I need here for part in 1, 2, 3. Part in 1, 2, 3. Fname equals input slash everybody underscore codes underscore E2024 underscore Q %02D underscore P %D dot txt. Format that with quest, comma, part, with open fname, write in text mode as out f dot write data stir part. Okay, now that should do it. Oh, not dot input. There, now I have all of my input. Okay. Now, Quest 10, for example. Okay. Okay, now I have to do the things that set up my times there, and I'm going to run this after shutting down OBS, so I will be right back. I just need to stop recording for a second, then I can run this, and then we'll be right back. Okay, I've run that. Now I'm going to do my times pipe format table. Okay, so first off, wow, my current laptop is much faster than it was before. So with this speed, 12 does kind of stick out. I should possibly reduce that. 20 is still the outlier, and the same person who commented on my optimized videos did say that Quest 20 Part 3 was a bit of a mess, and I have not looked at that code in well over a year, so I don't know, probably. So anyway, I'm going to go ahead and apply the suggestion to Part 19, even though I don't think it'll affect the time. I think although it will clean up the code a lot. And besides, I don't know that I knew generics in Go when I was doing Quest 19. So, and I haven't had a lot of practice with generics in Go. So, yeah, it'll be worth it. Quest 5 is also looking kind of heavy now. I mean, now that we're doing all the rest so fast. Oh, and 7. Okay. But let's go look at Quest 19. So, Quest 19, if you remember, and why should you? It was so long ago. There is no reason for you to remember. Yeah, Quest 19. There's no reason for you to remember anything here. It involved a decryption where you had to shuffle the cells around in order to do the decryption. So the final thing involved doing a huge number of rounds of operations instead of just 100. So how does this work? Okay, so in Quest 19, the original in Quest 19, I spent some time trying to build up this transform map. That's all that this is doing here. Now, with this, what do we have? We have height and width. Okay, so I'm going to pull this off into a separate function. First off, going to rename this to derive transform. Okay, now, okay, so we have the key, and we apparently need key. Do we really need grid in derive transform? Okay, it looks like the only thing we use grid for here in derive transform is this length of grid call, and this call here, where the only thing we're doing is we're doing length of row. So what I'm going to say is we can do that with just height and width. Okay, so this is just height. And this is just width. Now, okay, I want to make sure quest19.exe, that's that. And if I say go run quest19, I get the same answers still. Yes, okay. So, right, so I'm going to look here at derive transform, and what I did before, because the function rotate takes a grid that is a double array of bytes, two-dimensional array of bytes and a key. Because of that, then when I'm making this blank grid to derive my transform map, I can only fill it with byte values. So I have 1 to 255, and I fill them up here. But really what I want is I'd like to be able to do them all at once. So I'm going to go look at rotate, go to definition. Now rotate takes in here a grid, and the only thing it does with grid, so I'm going to see if I can make this generic in element type. Missing type constraint. Okay. Well, I actually like to think I could do any value there, so we'll just try that. Now, old stuff, that becomes E. Okay. And as far as I can tell, that worked. At least this seems to be happy with it. So Double check. Yep, we're still good. Okay, so now what I'm going to do, instead of doing this 255 at a time, I'm going to blank grid point. Okay, and what we're going to do is we're going to say that the and okay, so blank grid, it's not so much blank grid as it is working grid, and then make point 0 width for column index range width working grid bracket row IDX append working grid row IDX point of row IDX column IDX point, and then what we do is we just say this rotate, and then for point, and then this is transform at point equals there. And that should give us what we need. Yep, okay, so measure command. Milliseconds 23, so total seconds 0.023. Used to be 0.07. Okay, so it did in fact speed it up. Yeah, cut the time by 2/3. Of course, that doesn't cut our total time very much. But yes, there you go. There was no reason at all to stay with 200 and to limit myself to 256. The only reason is the types that I had on rotate. I had not wanted to change the types on rotate because I didn't want to mess up my part 2 answer. But by generifying it, I don't have to do that. I suppose I could have copied this and pasted it and made like a rotate point that was exactly like rotate but used points instead of bytes. I'm not quite sure why I didn't think of that at the time, or didn't even think of making it generic, but there. Making it generic makes the code, makes this code a little bit, quite a bit nicer. And does, as I said, speed it up. Okay, let's look at, actually, let's not look at Quest 20. The reason I'm going to say that is because if you saw the little jump in the video, I just spent well over half an hour, 45 minutes, I'm not quite sure, trying to rework Quest 20 to make it faster. The short version is that Quest 20 Part 2 is the slow part out of the 3 parts. And Quest 20 Part 2, the way I wound up solving it is by a breadth-first search. If you're familiar, here we can pull up the maybe we can pull up, yeah, we can pull up the problem, and the problem, you are flying a glider. The glider can only go straight, turn left, or turn right from where it was going. And you've got to fly a glider around a race where you hit points A, B, and C and return to the start. There's complications dealing with pluses move you up, minuses move you down, dots move you down slower, and you've got to, when you do the race in the glider, when you get back to S, you have to be at least a certain number of meters off the ground. So I initially did this with a breadth-first search, or at least in the version of this that is recorded there in Quest 20, the code. I do this with a breadth-first search that should that breadth-first search finds everywhere you can be after 1 tick, and then everywhere you can be after 2 ticks, and everywhere you can be after 3 ticks, and at every point it only considers the highest of all of the different possibilities that you could be after that long, at that spot pointed in that direction, having seen those particular waypoints that you've seen. And this finishes in under 3 seconds when I have OBS turned off. With OBS on, it's just over 3 seconds. And I said, oh, well, breadth-first search, the usual thing you would replace this with to make it faster is with a Dijkstra-based algorithm. And I tried a Dijkstra algorithm, and tried improvements, and it's just slower. I don't know why, but on this input, what I can come up with is just slower. It's ending up at 3.9 seconds instead of 3.1. And so, although you could watch me go through that, I don't really see the point. I'm not gonna put that up there. So I really don't see what I could do here for Quest Quest 20. In my first video, I did as much runtime profiling as I could not get anywhere. So, yeah, I think that's the only improvement that I'll do. I could go back and look at question 12, apply the optimization that was mentioned in the comments to figure out the spot where things should hit just using simple algebra. Maybe I will make another video of that, but I think this is at least interesting for the generifying that I did on Quest 19, and I will go and commit this change and push it up, and I will just forget about the changes I tried to make to Quest 20 because they did not help. Anyway, thank you. This shows I do respond to comments within 6 months. Hey, it's only been 4 months since the comments were left for me to notice.